So the next talk is online from Fang, the founder and CEO of Zettar. And he will talk about revolutionize data, large-scale data transport, at least AI and HPC. Fang, the floor is yours. You can hear us.
Since the release of ChatGPT at the end of 2022, globally, moving data at the scale and speed has become ever-rising business importance. The immense amount of data needs both AI and HPC to make sense of. Organizations that master this regard will be the leaders of the future. This slide summarizes the three major trends: the data tsunami, the IT paradigm shifts, and the need for real-time decisions. We'll discuss each as appropriate. The trio is creating a perfect storm. Data movement innovations are now mandatory to address it. The world is experiencing explosive data growth. The left side of the slide shows a few selected common data sources from top to bottom: generative AI, large language models, edge computing, precision medicine, and genome sequencing. The central arrow shows that the world's data volume grew from 3 EB in 1996 to a forecasted 200 ZB in 2030. The majority of other data movers were created a long time ago. The aged design means they struggle with bulk transferring hundreds of terabytes and multiple petabytes. They are simply unable to tackle high-speed streaming either. Please know that the initial training of a large language model needs hundreds of terabytes to multiple petabytes of data. Let me share with you a real example of explosive data growth. The healthcare and life science, or HLS, vertical generates about 30% of the world's data across all the verticals. DNA sequencing is the foundation of the important precision medicine field. This photo shows 3 established genome sequencing centers. There are hundreds of such centers globally. Look at the amount of data instruments can generate and the number of such instruments. Obviously, hundreds of terabytes to a few petabytes per day, without a doubt. How do you move the data to the upstream analytical pipelines? Next, let's take an overview of data movement challenges data-intensive organizations face today. Data tools and approaches are used, complex and slow. Overall, the capacity of data transfer is constrained. How can you achieve timely breakthroughs with such a setup? To address these challenges, we have developed 4 products. Instead of creating a suite, we integrate them tightly into a single application for simplicity of deployment and operation, consistency in usage, efficiency, and ease of scaling. Given the software was born in response to the ambitious data movement requirement of a DOE exascale computing preparation project, it was ahead of its time, but now, when facing explosive data growth, the timing is right. The typical data transfer is like watering plants in your yard. Moving data at the scale and speed is like moving water from a reservoir to feed a city. It demands storage, computing, networking, and the software to work in concert. Nevertheless, other data movers all have aged designs. As a result, they lack this integrated design approach. For example, a 2020 DOE evaluation showed that our software, with its balanced approach, maintains high transfer rates even for huge files, where Globus Grid FTP data rates plunge for such files. Zettar replaces a cumbersome toolbox of data movers with a single unified software data mover. It's simple, efficient, and handles both bulk and the real-time streaming data transfers for up to multiple hundred Gbps. Zettar unleashes the full potential of data for breakthrough innovations. When moving data at the scale and speed, you do need to understand the capability of your infrastructure, starting from the foundation stack, the storage. How do you figure out how fast your storage is and what's the latency? Running a storage sweep will answer part of the question. How do you do it? The storage sweep is a freeware on GitHub. Please download and learn it. Next, let's look at the computing aspect. When selecting processors, it's essential to pay attention to many things, including data transport. Fundamentally is an I/O-focused operation, so a high core count doesn't help. Some transfer tasks demands encryption and or compression. In this regard, using accelerators such as Intel QAT or QuickAssist technology is beneficial. Offloading operations to modern devices such as IPUs should help too. Some may say, we are still using 1 Gbps network. The entire institution only has got 10 Gbps. Well, let me mention that 100 Gbps links have become very common worldwide. Zettar has been using links with such a speed since late 2014. The current US DOE Energy Science Network, also known as ESNet, runs a backbone with many segments that have 800 Gbps or faster speeds. High-speed connection prices have been dropping steadily. Please check with your providers. Another unusual aspect is that Zettar works with a Tier 1 server partners to offer data movement appliances. You may wonder, why do it this way? Why can't we just obtain the software installed in our servers and be done with it? Moving data at the scale and speed is challenging. Very few IT professionals have the luxury of gaining expertise in many IT fields. Plus, making the entire infrastructure and the software work in concert is yet another formidable challenge. Furthermore, solution integration is not the job focus of most IT professionals. For complex jobs, businesses buy appliances such as these high-speed instruments. All of them are based on commodity servers too. So in our view, moving data at scale and speed should be offered in appliances. HPE, ASUS, and Intel are collaborating with Zettar to build data movement appliances using the latest server from each vendor and our ZX software. I will share with you the test results obtained so far. In brief, both bulk transfer and streaming transfer are at line rate 100 Gbps. Note that server A and B are connected with a 100 Gbps Ethernet connection, so we mask it out. Let me show you a live demo. So here are the building web interfaces. So server A and server B. So let's start. So you browse, select the source data, just pick one. And give the task a name. Yes, for demo 0. Select server B as the destination, and also tell it where to deposit the data at the destination and save. Then you will see it enumerates files and the sending. Go to server B and take a look. It's this one. It's transferring, and look at the mean transfer rate. I think in 11 seconds, it's done 128 gigabytes. Now, I would like to dispel a very typical misconception. Quite often, people confuse data traffic aggregation the same as a point-to-point data transport. This is not true at all. Data traffic aggregation is built upon many point-to-point data transport flows in conjunction with routing to direct the traffic to use certain selected links. This is a long-established technique. The tail sign is often it involves multiple data sources and destinations, but to achieve a high point-to-point data transport rate is immensely challenging. we have done it over years. For example, in late 2021 at SC21, we demonstrated to transfer 3 petabytes per day. Contrary to another vendor who claimed to transfer 1 petabytes per day, if you review its technical brief with 3 pairs, each pair formed using 2 high-power servers for specific file size too, the lack of efficiency is obvious, and so is the complexity. Therefore, watch out what you read. Zettar has been an engineering-centric company. As such, we may not have high visibility in the marketplace. Nevertheless, our deeds speak louder than words. So as is, we already have partnership and recognition from Tier 1 entities globally. Should you wish to get more information, I'm happy to answer your question now. You are also invited to email us and browse the Zettar website's resources page. Should you be interested in the data movement appliances, happy to put you in touch with either HP Europol or ASUS US. Thanks for listening to the talk. Any questions or comments? How are you? Yes, I'm here. Let's see. Can you hear me now? Yeah.
Can they have any question? So I have one. I see in the presentation that you move a big number of gigabytes very, very fast.
Yeah.
Did you test the limit? So how big can be the file that you can move that fast?
We have tested up to 4 TB, not terabyte. That's TB, that's power of 2, up to 4 TB per file.
Wow. And how long it took?
You just saw 128. That's a question. First, how good is your infrastructure? Software cannot make magic. Software runs according to the resources available, environmental resources, that's infrastructure. So for instance, like in DOE, we have an 800 Gbps backbone, and using cluster, you can move 4 terabytes per file, probably 20 seconds.
Is it working better or worse using one storage manager or another one? So do you find any difference between using BFS on behind or Ceph or another ones?
Storage is very important. So to answer your question, the storage, before you do any big data transfer, okay, you should always know the 2 factors about your storage. What is the throughput for the file size range you are interested in, and what is the latency of the storage? These can be benchmarked and found out. So knowing these, you don't really care about what storage to use as long as it's fast and its latency is slow. It's very low, okay? So I hope that answers your question.
Yep. Any other question from the audience? Yes, there's one here at the end of the room.
So if I understand properly, the limit for the data transfer rate is the theoretical bandwidth you have over the network. Is that correct? I mean, provided
No.
you have enough fast storage on both ends, then you can saturate the link you have over the networks?
That's a very good question. Network actually is important, but also you need to be concerned about the Linux kernel. We target Linux only, okay? So Linux has a high-speed interfaces. The older ones only has like a EPOL, okay? EPOLL. And the newer ones, and also AIO. The newer ones also have IOU ring, and another new one is also upcoming too. So the newer interfaces can help. But if you are using the, say, current standard Linux distribution, I'm afraid that even with our software per instance, that is per host, even with a fast storage, generous bandwidth, the highest you can do is probably around 200 Gbps as of today. Okay, so you need to use a clustering to help drive up the transfer rate. That the 3 petabytes I mentioned in my talk, that was done with 2 machines and 2 instances.
Thank you.
Any other question from the audience? So if no, let's thank again Tim Fang.
Thank you.